Productivity is a system one creates, always, in service to another. It functions as an invisible circuit board. Energy is pushed toward the end state.
Yes,
This
MVP
is
ready
the
for
final
launch.
integrated
I'll push
output
the code
for
and
which
monitor
the
the
entire
minutes.
architecture was
Let's sync
designed.
tomorrow on the funding
This
round.
energy, or activity, moves through the invisible traces of one's entanglements. These paths must be identified. The system is stabilized by the grounding, foundational ground plane of core values. This grounding must be specifically engineered as high power for massive output, high precision for isolated focus, or high speed for rapid iteration, depending on the requirements of the end state. This acts as the system's common return path. Through activity, the flow, or rate of energy, proceeds over time, output. It is the steady, kinetic
our MVP
momentum
launch
that
strategy.
carries
The
work
data
from
shows
initial
CRMVP
activity
strategy targets
toward the
these.
final
Welcome, team.
end state,
Today we launch our
ensuring
MVP.
the
This
circuit
scope
remains
distribution
live
is our
and
foundation.
productive.
Safe priorities guide our launch phases. This is our path to success.
Through intensity, focus is applied as a concentrated force or volume of energy or activity at any given moment. It is the sheer density of attention required to power the complex components and bypass potential stalls in the system. Through frequency, the regularity and rhythm of the energy pulses ensures consistency is completed. It is the consistent cadence of activity that keeps
October done.
the system
Metrics look solid.
synchronized
November,
and
let's nail
prevents
that
the
pitch.
stagnation
December's
that occurs
close. Finalize
when the
deck, ship the
flow
demo.
becomes
January's
intermittent.
here. Outreach time.
This
February,
rhythmic
close the
movement
round.
naturally generates interference, noise, the chaotic byproduct of high-frequency pulses moving through the traces. It represents
so
the
many
system's
things.
stresses
New
that must be
emails,
filtered
calls, what now?
by the grounding plane.
Hello? Yes, on it. Wait, another chat. Ugh, can't keep up.
To prevent signal distortion and maintain the clarity of the system's output, one must work to understand the sequence in which energy is pushed through the resistance of friction or obstacles. These cause energy to dissipate as waste or heat through the system they're creating. Once one decides to flood their system with energy, they must respect the capacity, internal and external infrastructures. This is the maximum amount of energy the traces can handle before failing.
Just can't keep going like this. It's over. I'm done. Burned out. Game over.
Welcome back to the Deep Dive. Today we're embarking on what I can only really describe as a bit of a grand experiment.
Yeah, it's definitely going to be an interesting one.
Right. We are taking two very distinct bodies of knowledge. These are universes that usually just do not talk to each other, and we're wiring them together to see if we can generate a spark.
I like the electrical pun there, considering our sources.
I couldn't resist. But seriously, on one side of the table, we have the high-speed, high-stakes world of Silicon Valley business strategy, specifically grounded in Eric Ries's modern classic, The Lean Startup.
Which is, for many people, the absolute Bible of how to build a company in the 21st century. It is all about agility, pivoting, and using scientific thinking in business.
Exactly. But then on the other side of the table, we have something much stranger. We have a dense, honestly almost esoteric technical manual called the Productivity Circuit.
It's an intense read.
It really is. It reads less like a self-help book and more like a schematic for a high-voltage electrical panel.
Mm-hmm.
It treats human work not as a psychological process, not as a management challenge, but strictly, brutally, as electrical engineering.
And it's just a fascinating juxtaposition. You have this modern business philosophy on one hand, and then the literal physics of energy transfer on the other.
Right.
And the reason we are mashing them together today is to answer a question that I think plagues every single person listening to this right now.
Right.
Why does so much of our hard work, the sweat, the late nights, the stress, Why does it feel like it just vanishes into thin air?
Yeah, it's the phantom workload.
Yeah.
You spend weeks on a project, you reorganize your entire file system, you write the code, draft the strategy doc, and then silence.
Nothing happens.
Exactly. Nothing happens, no impact, the world does not change. You are exhausted, but you haven't actually moved the needle.
It is the classic trap of confusing motion with progress. In physics terms, you are generating heat, but you aren't generating any light. And what we want to do today is explain why that happens.
And not using vague motivational quotes.
Right. No, we're using the hard laws of circuitry from this manual.
So to make this digestible, because these concepts can get pretty heady, we are going to anchor everything today in a story map. This is derived directly from our sources. We are going to follow a protagonist, let's just call him the engineer.
The engineer.
We're going to watch him struggle in a dark room. We're going to watch him fail. And then we're going to watch him completely rewire his entire approach to work using the principles from these two sources.
I love this approach because it takes the theory totally out of the abstract. We can actually see the mechanics in action.
So let's set the scene. Act I, the prime directive, or in service of.
Let's go into that dark room.
Picture a software engineer. He's smart, he's talented, and he is sitting in a room with the blinds drawn. It's maybe 2 a.m. The only light is the glow of 3 massive monitors.
We've all been there.
Oh, absolutely. And if you look at his hard drive, it is just a graveyard of finished work. He has folders upon folders of apps he has coded, tools he's built, intricate database architectures he has completely designed from scratch. He is working 18 hours a day.
He is, to use the source's exact term, thrashed by activity.
Thrashed, yes. But, and this is the crucial detail for you listening, none of it is launched. None of it is in the hands of a user.
None of it. And he sits there feeling this immense weight of unproductivity, even though he's probably typing 100 words a minute.
Right, so he opens the Productivity Circuit manual looking for a hack. Maybe he thinks he needs a better calendar app or a Pomodoro timer.
But page 1 doesn't give him a productivity tip. It gives him a strict commandment. Do you have the text there?
I do. Let me pull it up. It reads verbatim. Productivity is a system one creates always in service to another.
Let's just let that hang in the air for a second.
Yeah.
Always in service to another. That is a fundamental, almost violent shift in definition for most of us.
It really is. Because if I asked you if you were productive today, you would probably say, yeah, I wrote 5,000 words. Or, yes, I built the garden shed.
Right. You define it by the output you created.
Exactly. By the thing.
But the manual argues that building the thing is merely preparation. It is just potential energy. Think of a battery. A battery sitting on a shelf is full of energy, but it isn't doing anything. It isn't productive. It is just heavy.
It's just a heavy object.
Exactly. To be productive, that energy has to flow out of the battery and into something else.
And if you just loop the wire back to the battery, like plug it into itself.
That's a short circuit. You get sparks, you get heat, you might even melt the wire. But you do not power a light bulb. You don't turn a motor. And that is our engineer in the dark room. He is looping energy back to himself.
He is coding for the sake of coding.
Right. He is solving puzzles because he likes puzzles. It is a completely closed loop.
And this connects so perfectly to a concept from The Lean Startup by Eric Ries. He talks about this brilliant college kids in a dorm myth.
Oh yeah, the classic Silicon Valley myth.
They lock themselves away, they build something supposedly perfect, and then they release it to the world, only to find out.
That nobody cares. Ries calls this achieving failure.
Which has to be my favorite paradox in business literature. Achieving failure.
It is a devastating concept when you really think about it. It means you successfully executed the plan, you finished the code on time, you stayed under budget, the quality was super high, you achieved the project perfectly.
But you failed the business because you built something that literally nobody wanted.
Exactly. You achieved a short circuit.
So act I for our engineer is this realization. He looks at his hard drive and realizes those folders are not assets. They are evidence of a short circuit. He realizes that preparation is not productivity.
To be productive, he needs a recipient. He needs a load for his circuit in engineering terms.
So what does he do? He does something that feels very unnatural for a guy who likes dark rooms and code. He stops coding.
He closes the laptop.
He unplugs. He walks out of his apartment and goes down the street to a local medical clinic.
Now, why a clinic specifically?
Well, in our story map, he's been a patient there before. He's seen the chaos in the waiting room. He knows there's a receptionist, let's call her Sarah, who is just absolutely drowning.
So he goes there just to observe.
Right. He walks in and he sees Sarah. She is surrounded by yellow sticky notes. The phone is ringing off the hook. Patients are missing their appointments because their rides didn't show up. She's frantically trying to call taxis, call ambulances, call nephews to come pick up their aunts. It is high stress, high friction chaos.
And in that specific chaos, the engineer identifies the trace.
Ah, yes, the invisible traces of one's entanglements. That is the exact phrase from the manual.
It sounds kind of poetic, right? But in engineering, a trace is very literal. It is the copper line on a circuit board that connects component A to component B. It is the literal path that energy travels.
So in the real world of our story, the trace is the relationship.
Yes, exactly. It is the connection between the maker's skill and the recipient's need. The engineer has a skill. He knows how to structure data and automate complex processes.
And Sarah has a need. She needs to coordinate rides for patients.
So the trace is the potential path between his skill and her need.
And this brings us to the most important point of Act 1. You cannot engineer a circuit without knowing where the energy needs to go.
You can't wire a house if you don't know where the lights are going to be.
Exactly. So now that he has identified the other, meaning Sarah and the patients, he can move to Act 2, the architecture of purpose, or the vision.
Now, normally, this is where the typical engineer would run back home, lock the door, and spend 6 straight months building Uber for hospitals.
Right, he'd build the product.
Sure.
He would obsess over the logo, the color scheme, the back-end database, the login screen animation.
But the manual stops him right there. It asks him to define the end state. And it is very, very specific about what that means.
It says the end state is the final integrated output for which the entire architecture was designed.
Okay, so let's parse that for the listener. To the engineer, the integrated output usually looks like the software application itself. He thinks, I built the app, here's the file, that is the output.
But that is wrong. The app is just a transformer. It's just a switch on the board.
Yeah.
The actual output is the change in the physical world. In this specific case, the end state is the patient arrives at the doctor on time.
That is such a critical distinction. The code is not the point. The app is not the point. The physical patient sitting in the exam chair is the point.
And this aligns so perfectly with the pyramid structure in the lean startup. Eric Ries visualizes this triangle. At the bottom, the white foundation is vision.
Right.
So the vision is patients should get to their doctors efficiently. That rarely ever changes. Above that is strategy, the general plan of how to actually do it. And at the very top, the tiny little tip, is product.
And the product is just the current experiment.
Exactly. The product is totally ephemeral. It changes constantly. Maybe the product is an app. Maybe it is a dedicated hotline. Maybe it's a partnership with Uber.
If you fall in love with the product, you are doomed. You have to fall in love with the vision, the end state.
Because if the engineer thinks the app is the goal, he's going to measure his success by lines of code written.
Which is a vanity metric.
Right. But if he thinks the patient arrival is the goal, he measures success by rides completed, which is an actionable metric.
And that profound shift in mindset allows him to realize that maybe, just maybe, he doesn't actually need to write any code yet.
We're getting a little ahead of ourselves, though, because before he builds anything, even a prototype, the manual says he has to do something called stabilizing the ground. This takes us into Act 3.
This is one of the most technical and really profound parts of the productivity circuit source, and it is exactly where most people get their wires crossed.
So let's talk about grounding, because in a self-help context, grounding usually means like taking a deep breath or going outside and walking barefoot in the grass.
Yeah, or staying humble or something. No. In electronics, the ground is the return path. It is the 0-volt reference point. If you don't have a solid ground, your signal gets completely full of noise. You get static. The system becomes erratic and, frankly, dangerous.
So the engineer goes back to his desk. He clears off all those half-finished, unlaunched projects. He needs to stabilize his board, and the manual says the grounding plane is made of core values.
But it's not just a poster of nice words on the wall.
No, it says you have to engineer your grounding specifically for the exact type of energy you're handling.
And it gives 3 specific categories, and the catch is you have to choose one. You absolutely cannot be all 3.
Let's walk through them, because I think this is where the deep dive really adds some concrete value for you as a listener. The first category is high-power grounding.
Think of a massive hydroelectric dam, or a giant factory floor, or a national power grid. You are dealing with massive output and massive return current.
So this is for big, heavy lifting operations.
Right. If you're building a system to serve millions of people, or you're moving heavy physical goods, or running a huge logistics network like Amazon, You need high power grounding.
The traces have to be incredibly thick.
The components have to be robust. It is not about being fancy or cutting edge. It is about not melting when the massive load hits the system.
So the values here would be things like stability, reliability, safety, and scale.
Exactly. You do not want a move fast and break things attitude at a nuclear power plant. That's a catastrophic mismatch. You want high power stability.
Okay, that makes sense. Category 2 is high-speed grounding.
This is your classic startup world. This is 5G signals. This is all about rapid iteration and ambitious goals. The primary priority here is frequency. You want to send a signal, get a reflection, and send another one back instantly.
So the core values here are speed, adaptability, disruption.
Yes. The grounding plane here is specifically designed to reduce inductance, which is the resistance to change. You want to be able to pivot instantly. If you are building the next big social media app, you need high-speed grounding.
And finally, the third category, high-precision grounding.
This is for isolated focus. Think of a master watchmaker, or a neurosurgeon performing a delicate operation, or a scientific instrument measuring gravitational waves in deep space.
The manual actually talks about protecting the work from noise here.
Because in high-precision grounding, you are literally shielding the circuit from the outside world. You don't want the vibration of a passing truck out on the street to ruin the calibration of the laser. You need absolute silence. You need accuracy.
So let's look at our engineer. He is building a system for a local medical clinic. He is dealing with sensitive patient data. He is dealing with elderly, sick people who need to get to their dialysis appointments. Which grounding does he choose?
He has to choose high precision.
But why not high speed? I mean, it's a tech project, right?
Because if he moves fast and breaks things, an 80-year-old patient gets left in the rain, or extremely sensitive medical data gets leaked to the public, that is noise infecting the signal. Because the end state involves vulnerable people and specific sensitive data, the grounding must be precision.
This is such a crucial point to internalize. I think a lot of us try to have all three groundings at once. We tell ourselves, I want to be incredibly innovative and fast, which is high speed, but I also want to produce flawless, perfect work, which is high precision, and I want to reach millions of people immediately, which is high power.
And the manual is telling you that is physically impossible. You cannot run a high-power current through a delicate, high-precision trace. You will blow the fuse instantly. You have to choose. What is the primary nature of the work you are doing?
So the engineer makes his choice. He chooses high precision. He commits to isolated focus. He creates his zero-point reference.
Which basically means he now has a filter. If something comes in that doesn't help the patient get a ride safely, it is noise. He ignores it.
He has finally stabilized the board. Now, and only now, is he actually ready to turn the power on. Which brings us to Act 4, intensity, frequency, and flow, the concierge MVP.
This is the part of the story where the engineer usually quits because it requires him to do something that feels totally unscalable.
He goes back to the clinic every single morning at 8 a.m. sharp. He sits right next to Sarah, the receptionist, and he effectively becomes the software himself.
Right. In the lean startup, this is called the concierge minimum viable product.
So he really isn't coding at all.
Zero code. Sarah gets a request. Mrs. Johnson needs a ride at 10 a.m. She hands a sticky note to the engineer. He picks up his own personal smartphone. He calls the local taxi company. He negotiates the price. He writes down the confirmation number. He waits by the clinic door. When the taxi arrives, he walks Mrs. Johnson out to the car himself.
To an outsider, this looks totally ridiculous.
Yeah.
You have a high-paid, highly skilled software engineer basically doing the manual work of an assistant. It looks incredibly inefficient. It looks like he's wasting his valuable time.
It definitely looks like a waste, but it is actually the most efficient way to learn. The manual describes this process using 3 very specific physics terms: frequency, flow, and intensity.
Let's break those down. First, frequency.
That is the rhythm. He shows up every single day at 8 a.m. Consistency is completed, as the manual says. If the power cuts in and out, the system dies. He has to establish a reliable pulse.
Okay, next is flow.
That's the rate of energy over time. By doing this manually, he creates kinetic momentum. Mrs. Johnson actually gets to the doctor. The problem is physically being solved in the real world. The trace is going live.
And finally, intensity.
Sheer density of attention. This is the absolute key to the whole process. When you code an app alone in your room, your attention is entirely on the code. The syntax, the logic loops, the database calls. But when you are the concierge, your attention is 100% on the friction.
Give me a concrete example of that friction.
Okay, so he calls the taxi company, right? And they put him on hold for 10 straight minutes. He feels that frustration viscerally. He sees Mrs. Johnson physically struggle to pull open the heavy car door. He notices that she can't read the text message confirmation he sent her because the font on her phone is way too small.
These are things he never, ever would have known if he was just sitting in his dark room coding.
Exactly. If he built the app first, he would have spent 3 entire months building an intricate text message confirmation system, only to deploy it and find out later that none of the elderly patients can even read it. By doing it manually, he learns that in 3 seconds. He applies his intensity to the actual transfer of value.
This connects so well to the concept of small batches in the lean startup. There's that famous story in the book about stuffing envelopes.
Oh, The Father and the Daughters. It is an absolute classic.
Retell that for us because it illustrates this flow concept perfectly.
So, a father challenges his 2 young daughters. They have a task. They have to fold, stuff, stamp, and address 100 newsletters. He asks them, what is the fastest way to do it?
And the kids do what basically all of us intuitively think is the most efficient way. They use large batches.
Right. They say, we will fold all 100 letters first. Then we will stuff all 100 into the envelopes. Then we will stamp all 100 envelopes in a row.
It feels faster because you get into a rhythm. You become like a robot on an assembly line. Fold, fold, fold.
But the dad decides to do single piece flow. Fold 1 letter, stuff 1 envelope, stamp 1 envelope. Fold, stuff, stamp. 1 complete cycle at a time. And he absolutely crushes them. He beats them easily.
Why does that work?
There are 2 main reasons. First, the actual physical movement of stacking and restacking piles of paper takes way more time than you think. But the real killer, the absolute destroyer of productivity, is the hidden defect. Imagine the girls fold all 100 letters, then they pick up the first envelope to start stuffing, and they realize they folded the paper slightly too wide and it doesn't fit into the envelope.
Oh no, that's awful.
Now they have to unfold and completely refold all 100 letters. That is rework. That is massive, demoralizing waste.
Whereas the dad would realize the mistake on the very first envelope.
Exactly. He would fail once, adjust his folding technique, and sail smoothly through the other 99. Our engineer at the clinic is doing single piece flow. He's doing 1 patient ride at a time. He is debugging the real-world process in real time. He is minimizing the time he spends going through the build, measure, learn loop.
So he is successfully traveling the trace. He is proving day after day that the energy can get from A to B. But now, because it's actually working, things start to get noisy. Which brings us to Act V, filtering the chaos.
Because success is highly magnetic, when you start moving energy effectively out in the real world, you generate a field, you attract attention.
The clinic is running way smoother. People are noticing the change. The engineer takes a picture of his little manual setup and posts it on social media, and suddenly his phone blows up. He gets 500 likes. He gets direct messages pouring in. Hey, can you add a feature where patients can order a coffee on the way? Or, hey, this is a cool system. Can you make it work for my dog walking business?
And the manual explicitly calls this interference, the chaotic byproduct of high-frequency pulses.
Now, in a normal startup context, this looks like pure opportunity. It looks like market validation. You'd think, look at all these feature requests. People love us. We're going viral.
But remember his grounding. He purposefully grounded his board in high precision. He has to look at these likes and these random feature requests and ask himself very strictly, is this signal or is this noise?
And this is exactly where the lean startup concept of vanity metrics versus actionable metrics comes into play.
Vanity metrics make you feel amazing. I got 1,000 likes. I have 50 new feature requests in my inbox. We got covered by a tech blog. But do any of those numbers tell you if the system is actually working? No. The only metric that matters to the engineer is, did the vulnerable patient get to the doctor safely and on time? That is the actionable metric.
But what about that request to add a coffee ordering feature? I mean, that sounds kind of nice. It would delight the customers, wouldn't it? Why is that considered dangerous?
Because it creates resistance.
Define that for us in this context.
The manual defines resistance as friction that causes energy to dissipate as waste or heat. If the engineer spends a full week coding a fancy coffee ordering button, and the patients who, again, are mostly 80 years old and highly anxious about their upcoming medical appointments never actually press it, what happened to all that engineering energy?
It turned into heat. It was definitely effort, but it wasn't productivity.
It vanished completely. It did not move the needle on the end state whatsoever.
So the grounding plane acts as a safety sink.
Exactly. A good ground takes that excess energy, the noise, the distraction, the vanity metrics, and safely dumps it straight into the earth so it doesn't fry the circuit board. The engineer has to look at that coffee request and say no. He has to look at the podcast interview invite and say no. He has to dump the noise to protect the core signal.
That takes incredible discipline.
Hmm.
It is so hard to say no to things that look and feel like success.
And that is exactly why you have to engineer the grounding before you turn the power on. If you wait until the phone is ringing off the hook to decide what your values are, you will cave. You will try to please everyone. You'll try to switch to high-speed grounding in the middle of a high-precision task, and you will crash the entire system.
So he ignores the noise. He stays disciplined. He keeps the flow incredibly clean. He focuses entirely on Sarah and the patients. But now he hits a hard physical wall. Act 6, respecting capacity.
Because he's still doing all of this manually, right?
Yeah, he is. And he's doing a really great job.
Mhm.
But because the system works so well now, the doctors realize they can start scheduling more patients. Suddenly, it is not 10 rides a day, it's 50. Then it's 100. Then it's 500 rides a week.
The engineer is just human. He has strict biological limits. He physically cannot make 500 phone calls a morning.
He's running around the waiting room sweating. He's
Yeah.
missing calls. He's making routing mistakes. He's getting cranky with the patients.
The manual has a very stern warning right here about capacity. It defines it as the maximum amount of energy a system's traces can handle before failing.
Which is burnout.
Game over, as the source text says. When you push too much current through a wire that isn't thick enough, it doesn't just run a little slower, it actually melts. The connection violently breaks.
So he is at the absolute breaking point, and this is the moment, and only this exact moment, where he opens the laptop again.
This is the pivot to automation. And look at how drastically different it is from his approach in Act 1.
In Act 1, he was just guessing. He was building based on a fantasy in his head.
Now he is paving the cow path. He knows exactly what the software needs to do. Input name, select time, send SMS to dispatcher B, confirm receipt with large font. He has executed this loop 1,000 times by hand. He has felt every ounce of friction. He has smoothed out the physical process.
He isn't inventing the process anymore. He is freezing a proven process into code.
This connects beautifully to the engine of growth concept in the lean startup. You do not build the engine until you have a car that can roll. Now that he has a proven, frictionless process, he writes the code to solve a capacity problem, not a hypothetical feature problem.
And when he launches that code,
It works immediately because it is just a harder, faster version of what was already happening perfectly in the real world. The energy flows seamlessly from the server to the receptionist to the patient. The circuit is finally closed.
and the engineer can step back. He isn't the wire anymore. He is the architect of the wire.
That is the ultimate transition from operator to engineer. But the paradox is he could only get there by being the operator first.
So the energy flow finally reaches the end state at scale. The work is realized and transformed into its intended result. The code wasn't the product. The system of service was the product. The code was just the final hard trace laid down over the path he walked manually.
Precisely. It's a beautiful execution.
So it's a happy ending. The clinic is humming along. Patients are getting their rides perfectly. Sarah's happy. But stories in business rarely just end there. We have a sequel discussion in our outline that we need to hit.
There is always a sequel, and this one introduces a massive new danger.
So the clinic director comes to the engineer. She says, "This is amazing. You completely saved us. Now I want you to roll this exact system out to all 10 of our locations across the state, and I want it done by next month."
Uh-oh.
What's the problem? The software works perfectly. Just copy-paste the code, right? Deploy it to the other servers.
It is never that simple. Remember his grounding.
High precision, isolated focus on this one specific clinic.
High precision scales very, very poorly. It relies on specific, highly localized knowledge. The software he wrote might be deeply customized to the quirks of this one location, like the specific driver for this clinic likes to park around the back by the dumpsters. Or the system knows Mrs. Johnson is deaf in her left ear, so the driver needs to approach from the right.
So if he just tries to blind deploy that to 10 other clinics,
It will fail spectacularly. The end state has fundamentally changed. The requirement is no longer perfect, bespoke service for this one room. The requirement is now massive output.
so he needs to change his grounding entirely to high power.
He has to rip up the floorboards. High power grounding requires massive return currents. That means standardization. He has to build a system that works completely without him.
This connects directly to the viral loop or the sticky engine of growth in the lean startup.
Ideally, yes. If you want to scale, the system must feed itself. If every new clinic requires the engineer to physically fly there, spend a week holding the staff's hands, and customizing the code base for their specific parking lot, the viral coefficient is 0. He is the bottleneck.
So to switch to high power, he might actually have to make the product worse.
In a specific sense, yes. He has to intentionally remove those super customized high-precision features that the first clinic absolutely loved, but that do not cleanly apply to the others. He has to trade precision for power. He has to build a boring, robust, universal protocol that complete strangers can follow without his help.
That is a really tough ego check. You have to stop being the artisan hero who creates a bespoke masterpiece and start being the industrialist who builds a reliable, unsexy power grid.
It really is. But if you try to scale high precision, if you try to force your obsessive perfectionism onto a mass scale without thickening the traces and standardizing fusion, you generate massive heat. Resistance scales way faster than value.
And you melt the board.
And you melt yourself in the process.
This is a lot to take in. We have gone all the way from isolated dark rooms to chaotic clinics to massive industrial grids. Let's bring this back to the common return path. Let's bring it back to you, the listener, sitting at your desk right now.
Let's synthesize this, because we've thrown a lot of heavy metaphors around today.
We started with the idea that productivity is not just a to-do list of tasks. It is a live electrical circuit.
And a circuit must be closed to function. Remember the prime directive from the very beginning. Productivity is a system one creates always in service to another. If you do not have a recipient, you do not have a circuit. You just have sparks in the dark.
Then we talked about finding the trace. You have to identify the actual physical gap between your skill and someone else's desperate need. You have to leave the dark room and go find your Sarah.
Then you stabilize the ground. You have to consciously choose your values. Are you building for precision, which is quality, speed, which is innovation, or power, which is scale? You cannot be all three simultaneously. You have to engineer your board for the specific type of energy you are actually handling.
Then you generate flow through intensity. You do the concierge MVP. You do the unscalable work manually. You stuff the envelopes one by one. You travel the trace yourself, feeling every bit of friction before you ever try to automate it.
Then you filter the interference. You use your grounding plane to forcefully say no to vanity metrics and distractions that generate heat but not light.
And finally, you respect capacity. You automate only when the sheer volume demands it, laying down hard traces over the exact path you've already manually paved.
It is a complete holistic arc. It completely redefines what it actually means to be busy.
It definitely forces me to look at my own inbox totally differently. I'm sitting here thinking about the last 5 emails I sent today. And I'm asking myself, did that email close a loop? Did it land on a recipient who actually needed it? Or was it just resistance in the wire?
Were you generating light or just heat? That is the ultimate question we all have to answer.
And I think the most provocative takeaway for me thinking about all of this is about that mismatch we talked about, what I'd call grounding anxiety.
Oh, say more about that. That's an interesting term.
I think so many of us out there are suffering from chronic grounding anxiety. We're working in corporate jobs or startups that aggressively demand high-speed results. Get it done yesterday, pivot, innovate, break things. But as individuals, we are approaching the work with high-precision perfectionism. We desperately want it to be flawless, but we also want it to be done instantly.
We are essentially trying to be a delicate watchmaker in a factory that builds heavy sledgehammers.
Right, exactly. And the Productivity Circuit manual says that isn't just difficult to pull off, it is physically impossible. You will burn out. The physics will absolutely win every time.
You have to choose. What is the system actually designed for? Because if you don't make the choice, the system will fail on its own terms.
So that is your mission, listeners. Find your trace, stabilize your ground, and close the circuit.
Until the circuit closes, it's really just sparks in the dark.
Thanks for listening to The Deep Dive. We'll see you next time.